Hi, I'm Dan Peterjohn, and I'm going to show you how to do number 29 for homework 5.3. For this, we're given three matrices, x1, x2, and x3 right here. And then we're given a system of derivative of x is equal to this matrix, which we can call A, times the x matrix. So our goals are to first verify that x1, x2, and x3 are solutions of the system. Then our second is to use the Wronskian to show that x1, x2, and x3 are linearly independent. And then 3, we write a general solution. Alright, so first we'll verify that x1, x2, and x3 are solutions of the system. And we do this by just plugging the matrices in. So we take our x1 matrix and we plug it into the system right here. So as you can see, the derivative of x1 is equal to the A matrix times the x1 matrix. So what we'll do is we'll plug in our x1 right here, and for the first part I just distribute the e to the negative 2t on both sides, right here and right here. And then for the next step, I take the derivative of this left matrix on the matrix on the left side. And when you take the derivative of e, you just bring the exponent and you take the derivative of that and just times it. So negative 2 times 3 is negative 6. Negative 2 times negative 2 is 4. And negative 2 times 2 is negative 4, and so on. You know, derivatives. Alright, for the right side, what we'll do is we'll multiply across, multiply these two matrices, the A matrix times the X matrix right here. And the way to do that is we take the row and we times it by the sum of the products of each entry of the column of the other matrix. So what we'll do is negative 8 times 3e to the negative 2t, which is negative 24, plus negative 11 times negative 2e to the negative 2t, and that becomes negative, that becomes 22 negative 2t, e to the negative 2t. Lastly, last entry times these two entries together, negative 2 times 2e to the negative 2t, and that becomes negative 4e to the negative 2t. So then you just add all these products up, and then you do that for the next. You do that next for the next row and times it by this column, like we just did. Same thing right here. This one times this one, this one times this one, this one times this one. Add those all up, and then what you have is you can see that both matrices are equal to each other, so we verify that x1 is a solution to the system. Alright, so we'll do x2 just like we did. We plug in the x1 matrix in here, distribute the e to the t, then we take the derivative of the left side right here. It just kind of stays the same because you bring the 1 down, it doesn't really affect anything. And then you just times across, or you multiply the matrices. So row times column, row times column, row times column, and then add these some of the products right here. And then you verified that x2 is a solution. And then for x3, do the same thing. E to the negative t, distribute that right here on each side right here. And then you take derivative of the left side, multiply the two matrices on the right side, and then you verify that the x3 is a solution to the system because both sides are equal to each other. Left hand is equal to the right side. Alright, for the Wronskian, what we do is we take all three matrices, and the first matrix, x1, is the first column, and then the x2 is the second column, x3 is the third column. And what we're doing is we take the determinant of this, that's why I have these straight lines instead of brackets, And then what we know about a 3x3 is we can do a trick to find the determinant really fast. And what we do is we take the first two entries and we just copy them over on the outside right here, and we draw some lines right here. So the red lines is what we're going to, the red lines will be our left side right here, and then our blue side, we're going to subtract it from the red. So what we do is we find the product for each line. So 3 times e to the negative 2t times negative e to the t times 0. And then we find the sum of the products for all of that. So product of this is 0, e to the t times negative e times 2e to the negative 2t. As you can see, that's the whole product of that becomes negative 2e to the t. And then lastly, the last diagonal, negative 2e to the 2t. And so all this, the sum of this, of all the red, is negative 4e to the 2t. Okay, so we do the same thing for the blue lines. So find the product of each line and then sum them all together. So let's say first line, 2e to the negative 2t times negative e to the t times e to the 3t. You can see that becomes negative 2 e to the 2t. And then right here, this second line, that becomes negative 3 e to the 2t. And then this 0 just makes the whole thing 0. So the sum of all these products is equal to negative 5 e to the 2t. So what we do is we take the red and we subtract it by the blue. So negative 4 e to the 2t minus negative 5 e to the 2t, and that becomes 5 plus negative 4 blah 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 e to the 2t kind of thing, and that becomes e to the 2t, and then we have our Wronskian. And then lastly, we got to make a general solution for third part. And then you can see this is just kind of like the general way of writing it. So we'll take C1 times the matrix C of x1, C2 times matrix C of x2, C3 times matrix C of x3. So as you can see, I put my matrix C in right here, and then you just multiply these in, and then you can see the C just goes in nicely right here, and then C2, C3. Then we add all these matrices together. So it becomes negative 3c1 e to the negative 2t plus c2 e to the t plus c3 e to the 3t for the first entry, or for the first row, and then negative 2c1 e to the negative 2t minus c2 e to the t negative c3 e to the 3t, and then 2c1 e to the negative 2t plus c2 to the t, e to the t. And then this is a 0 because anything times 0 is 0. So that is our general solution right there. And then we're done.